All right, we're moving on to section 5.2 today. So 5.2 is about bisectors. So we're going to talk about perpendicular bisectors and angle bisectors in this section in reference to triangles. So in a triangle, you have three sides, which means you have three possible perpendicular bisectors. So this one we're going to talk about perpendicular bisectors. So the word perpendicular means to cross at a right angle, so see those right angles. And bisector means to cut into two equal pieces. So the reason I know that RM is a perpendicular bisector is because it's crossing at a right angle, and this side is cut into two equal pieces. So perpendicular and bisector. Same thing here, MS is a perpendicular bisector of side PQ. MT is a perpendicular bisector of side NQ. So what's so special about perpendicular bisectors in triangles? So perpendicular bisectors, if they are drawn, will all cross at one point. They will all intersect at one point, in this case point M. And they call that being concurrent. So concurrent means that they all cross at the same point. They all intersect at the same point. In this case, point M. So point M is called the point of concurrency. Right? The point where all your perpendicular bisectors intersect. Right, where they cross. And they have a special name for that point of concurrency. They call it the circumcenter. The circumcenter. So where all your perpendicular bisectors cross is called the circumcenter. Now what's so special about the circumcenter, right? Why do we need to know this? So that's where your Circumcenter Theorem comes up. So here's your circumcenter. And what the Circumcenter Theorem says is that it should be equidistant to every vertex of your triangle. So M to N is the same as M to P, is the same as M to Q, the same distance to every vertex. So that's what this theorem is doing. That's what this theorem is telling you. If you have a bunch of perpendicular bisectors, they're all going to cross at the circumcenter, and that circumcenter is equidistant to every vertex of your triangle, every corner of your triangle. So let's actually use it. Where might they use this in real life? I guess I should go back to that. A lot of times they'll use this with like let's say a bathroom, right? If you want to put up porta potties up where, they're accessible from all stages at a concert, right? There's 3 different stages, and you want to make sure that there's porta potties in like a central location. This would be a good thing to talk about, the circumcenter. Or building a mall and making sure that, everything is equidistant, stuff like that. All right, so moving on. HD, JD, and KD are all perpendicular bisectors. So let's take that for a minute. KD is a perpendicular bisector. So we know if this is 17, this is 17. JD is a perpendicular bisector. So if this is 15, this is 15. HD is a perpendicular, oops, that's a right angle, perpendicular bisector. So if this is 16, I'm going to do 3, sorry. This is 16. So all of that is just from that, right? Just perpendicular bisectors. Which means point D is called your circumcenter. So perpendicular bisectors all cross at the circumcenter. All right, let's go. DG. D to G. So remember, what's the one thing we learned about circumcenter is it's equidistant to every vertex. So D to G is the same as D to E, is the same as D to F, which they wrote as 19. So DE is 19, DG is 19. And actually we have both of those here. DG is 19 and DE is 19. And that was the actual circumcenter theorem there. EK, we already filled that in. That was because of that word bisector, right? We knew those were equal. And then FJ is 15. Again, bisector equal. So applying what we know. Next one says find the circumcenter. So when you're going with a graph, it's really nice when they're right triangles on the graph because you can just graph your perpendicular bisector. So what is it, 0 to 4, so halfway would be 2. And we want to go straight up. Alright, so that'd be perpendicular and a bisector. Alright, so there's my perpendicular bisector of that side. And then what is it, 0 to 6, so halfway would be 3. So that'll be my perpendicular bisector of this side. And we don't have to do the other side because that's where they actually meet. So your circumcenter is at 1, 2, 3. 2, 3 is where your circumcenter is. It's where your perpendicular bisectors cross. All right, let's do the next one. It looks like we're going 0 to 5, so it looks like that's going to be a half point. So we're at 2.5. Trying to graph nicely here. And then 0 to -8, which halfway would be -4. So here we are right here. My circumcenter is at -4, positive 2.5. So graph those two perpendicular bisectors, they will cross. Alright, so moving away from perpendicular bisectors, now we're going to talk about angle bisectors. So this one's all about angle bisectors. So notice here AG is cutting this angle into two congruent angles. AH is cutting this angle into two congruent angles. And AJ. So those are my angle bisectors. Again, notice they're concurrent at point A. So our point of concurrency is point A. And we call that point of concurrency the incenter. So incenter is where all my angle bisectors intersect. What's so special about the incenter? So the incenter, here's my incenter, right? AG, AH, and AJ are all crossing there. What's so special is from the incenter to each side. So from A to B, which is to side GH, AB is to side GH, AC and AD from the incenter to each side should be the same length. Okay, should be the same length. All right, let's try some out. So we're going to read PC and PD are angle bisectors. Angle bisectors. So PC, well, if that's an angle bisector, if this is 36, this is 36. And PD, well, there's nothing there, but I know those are equal. So you can even, if you want to put little rainbows there, just to remind yourself. find each measure. So this one says find the distance from P to side CE. So from P to side CE, remember from the incenter, so P is the incenter. Remember from the incenter to each side to be the same length. So it looks like from P to side CD is actually 9, right? Which means P to side CE should also be 9 units. The measure of angle PDE. Measure of angle PDE. We want this angle right here. So we're going to look at a total triangle. We're going to say a total triangle is 180 degrees. We're going to subtract out the 40 we already have, and the 36, and the other 36, and we're going to be left with a number. Minus 40 and 36. 68. But then realize, you know, half goes in each because of that bisect. So 68, cut it in half. You get 34 degrees. So that means 34 goes in here, and 34 goes in here. So you still have to use the triangle as 180. Don't forget the stuff you already know here. Next one, KX and KZ. KX is an angle bisector, so you know this has to be 18. And KZ is an angle bisector, you know these are equal. So this says find the distance from K to YZ. So K to side YZ. We want the distance. Again, remember K is your incenter, so K is the incenter. And the distance from K to this side is 33, so the distance from K to this side should be 33. And then the last one says find the measure of angle KZY, KZY. So we're going to do the same thing. We have 180 degrees in a triangle, minus the 39 we already had, and the 2 18s we already had. So 180 minus 39 minus 18 and 18, and we get 105. And then remember you want half in each, so 105 divided by 2, and you get that each angle is 52.5. And don't freak out if you get a decimal, that's a nice answer still. So just a quick recap before you get on to your homework. Perpendicular bisectors all cross at the circumcenter, and the circumcenter is equidistant to every vertex. Angle bisectors all cross at the incenter, and the incenter is equidistant to every side. Alright, so get on your homework and get it done. Get it turned in. Show all your work.